Let's do one more example of graphically adding vectors. We're going to add these two displacement vectors by choosing a scale so that it fits on our paper. 1 centimeter is equal to 10 meters. Then we need to draw the first vector relative to some fixed direction. So if upwards is north, then we see that the angle here is 15 degrees to the north of east. So east points to the right, so 15 degrees to the north of that would look something like this. 15 degrees, you can imagine rotating 15 degrees to the north of east, and the length of that vector would be 6.5 centimeters. There's our 15-degree angle. We're going to draw vector number 2 right here at this arrow point, and I always look at the direction first. I need to draw this at 63 degrees north of east. We're going to write east right there, and now we're going to turn that 63 degrees north, like that. We're going to draw it to the proper length. We're going to now draw our resultant by starting where we started and ending where we ended. If we measure that line, it might have a length of perhaps 11 centimeters, which means our displacement vector will have a magnitude of 110 meters. And then we need an angle, and that angle needs to be measured relative to a fixed reference line. I'm going to measure it here relative to east with my protractor, 35 degrees north of east. If instead I wanted to measure that same resultant relative to north, then I would get my protractor out and I would measure that angle, which I've labeled phi. And I would report that as so many degrees east of north, like 55 degrees east of north. This slide is going to reinforce the idea that the order in which you add vectors makes no difference. If we have these three vectors and I add them in that order, I'll get a resultant that looks like that. I went to the trouble and added these vectors in every possible combination that you could add them. Notice that if you start where you started and you end where you ended, the order of adding the vectors makes absolutely no difference. You notice that the length, that is the magnitude of the resultant, and the direction of the resultant are completely unchanged.